Now, in a surprising turn of events, the book I have on here is actually similar to the one that you have. I came in last Thursday and worked on some stuff, but I checked. We are back on the same page now, so we shouldn't be too lost. In this next lesson, / in this final lesson, we will be interpreting statistical data through the lens of basically where stuff fits in terms of how constant it can be, how likely is something fits within a range. So let's introduce this. So if we were talking about what is the mean height of all the students in our school, what's mean again? Okay, what's the average height of all the students in our school? By the way, anyone want to make a guess? What do you guess?
5'7". 5'8".
Sure. So you're talking on imperial? Sure, fair enough. Fair guesses. You can determine this correct answer. There's one way to for sure find the average. The way you can for sure find the average is measure every single student in the school, take the average. Doesn't seem really realistic. Now that would be the population mean, and that would be the correct mean of the population. But even in a school like this, it's really unlikely we'll do exactly that. So instead we can do a random sample. We can take some sample, maybe say measure the height of 5 classes. You probably want a split where there's grade 10s, 11s, and 12s, because theoretically the average grade 12 will be taller than the average grade 10, right? So you'll want to mix, you'll want to make sure there's both male and female students. You'll want to try to get a representative sample. But if you can get a representative sample, we could try to estimate the average by using a sample mean, right? We could take the mean of some sample, and if the representative sample is similar to the population, then it should be decent. Now, how confident would we be, though, that the sample mean is the same as the population? Well, not exactly, but James is alluding to they should be close. Hopefully they're close, depending on how our sample is. Now, if we take data from a sample and calculate the mean, we can never be sure it's going to be exactly the same. It'd be pretty rare, actually, to get exactly the same. The best we can hope for is it'll be close. And depending on how close is how good the sample is. We can determine a range of values around the sample mean that we're confident that the population mean lies in. And this is like, who's done graphing in chem or in bio, where you have to graph and you put in your points, but then you have to put error bars.
Oh, no.
You haven't done that yet? So maybe you're graphing a bunch of points on a graph, and it's like you first measure at this point, it's here, but because there's some possible error in your measurement, maybe there's some possible error in the depth setup itself, you might just draw a circle. It says, oh, it's within here, or maybe it's even you're going, oh, it could be from here to here, and you do the same thing with this, the same thing with this, same thing with this, same thing with this, same thing with this, whatever, and each one you're saying, well, it could be here, but it might be plus or minus a little bit. Is that something you've done, or that only at 30? Haven't gone through yet? You've seen it? Okay. As you get into higher levels of sciences, it'll be assumed every time you're taking data that you're including some error range within it. Similarly, in statistics, we're saying that if we're taking a sample and finding something within it, it should be related to the population, but we don't know exactly. Now, in this case, the range of values from 65 to 70 is, oh, sorry. Okay, this range of values from 65 to 70 is an interval. Now this interval could be written as 67.5 plus or minus 2.5 inches. Right? This is the same as this. 2.5 above or below this day. And you ever booked like flights?
No.
So say you're going on like Kayak or on whatever, some website, Expedia. Often there's an option of, you want to fly on February 24th or something like that. And you want to fly until March 6th or whatever the days are. But you might have the option of, go plus or minus 1 day or plus or minus 2 days. What you're saying is, I'm happy to fly right around here or right around here. Or maybe I need to be exact, or maybe I need to be close. And that's basically what this is how big is the range of what we're looking at. In this case, this height case, the interval of 65 to 70 is 67.5 with a 2.5 inch margin of error. It's the stuff from 65 to 70, everything within 2.5 of 67.5. How about this interval? The range of values from 63 to 72 is also an interval. Okay, that's an interval. Now how would we find what the range or the margin of error is there? Well, what's the middle of this interval? 67.5. 67.5. And that's plus or minus how much? 63 to 72. Right, so 67.5 plus 4.5 is 72. 67.5 minus 4.5 is 63. So the margin of error is 4.5 inches. So interval, the way we change interval into the margin of error is take the middle and figure how far each edge is. Sorry, I skipped this earlier. If the sample mean of this population was 67.5 inches, it's not moving. Sorry, guys. If the sample mean was 67.5 inches, we can't be sure that the population is 67.5, but we'd be reasonably confident that it's probably between 65 and 70, depending on the sample. We'd be very confident that if we kind of extend this a bit more, we extend this by another 2 inches on both sides. You notice that the midpoint is the same, 67.5. This is a bigger margin of error. In the first case, we had a margin of error of 2.5. Now we have a margin of error of 4.5. So we should be more confident. And this is what we call confidence. So my confidence level is higher that the mean would be within this second interval than in the first interval. Are we sort of tracking or like this is totally weird? Okay. So interval is like the range of values. If it's a bigger range of values, you likely have a bigger degree of confidence or confidence level. And the confidence interval is that interval. Well, let's get into the math and look at how this works. Okay, so what about this? What about voting? You guys probably saw today, Justin Trudeau has said he will be resigning as Prime Minister once the Liberals have appointed a new leader. They're going through a leadership search as of today. So we will be having a new Prime Minister at some point in the next year. Now, at some point in this next year. We don't know when the election will be called, but at some point there will be a new Prime Minister. And whatever you think of that, you're going to start hearing how much about polling results and percentage of Canadians voting certain things. And in Alberta, that percentage will be higher for Conservatives, and if you look west of us, it will be higher for NDP and Liberal. But if you're looking at the population of the country in total, you might ask the question, like, what percentage of Canadians vote for the Conservative Party? Now, it's not likely that you'd be able to survey every single Canadian voter, and even if I did, let's say I was surveying this class, there's a good chance that some of you might feel embarrassed about what you would vote for politically, or you're under 18 so you can't vote. So I may not even get a perfect sample, even if I could survey everyone.
If we could.
But let's say we could take a sample. So take a sample. Maybe a poll organization conducts an opinion poll. Their aim is to determine the percentage of Canadian voters who would vote for the Conservative Party. They released this data. In this poll, which was an opinion poll, and it was a voluntary opinion poll, so only people who wanted to answer it answered it. 38% of Canadian voters. Now, 38% of Canadian voters, let's think. What does this say, 30% of all Canadian voters?
Nope.
30%
Voters, Canadian voters.
of the Canadian voters who are serving. They would vote for the Conservative Party. Now, these results are accurate within 3.5 percentage points, 19 times out of 20. Okay, wait. So they're saying a few different things here. So in this example, they use 38% as an estimate of the true proportion of Canadian voters who vote for the Conservative Party. This is their guess of the amount of voters who vote for the Conservatives. But there's a margin of error. They're saying the margin of error is plus or minus 3.5%. They're saying that we think that the amount of voters who will vote Conservative is somewhere between 34.5% and 41.5%. We're saying it's somewhere in there. And we're confident that it's within there. We're confident within that range 19 times out of 20. We're saying we're 95% confident that the amount of Canadians who will vote for the Conservatives is somewhere between 34 point whatever and 41 point whatever. That's what this is saying. So this confidence interval is from here to here, and the confidence level is 19 out of 20, 95%. Oh, sorry, I did that before. This. So confidence level, 95%, and the interval that they're confident about is from this 34.5 to 41. Does that help interpret the data? This is actually part of why there's often so many complaints about election. So you guys probably remember there was this recent election in the States. It was received a little bit of publicity. An election between Kamala Harris and Donald Trump, and the polling was really close. It was really hard to say what was going to happen. But if you go back, there was an election between Trump and Biden 4 years ago, and then there was an election between Trump and Hillary Clinton before that. And this was one where the polling, in general, that election, it was assumed that Hillary Clinton was going to win. That was what the pollers thought. However, the confidence interval that was talked about, you're talking about numbers that are about, in American elections, usually 49% votes for one, 50% votes for another, 1% votes for kind of the other option. So in general, it's very, very close at a percentage. And they were saying, we think that, let's say, 50% of voters vote for Clinton, and 49% of voters vote for Trump, or so. And they said this data is accurate to say plus or minus 0.5% or whatever. Well, if you think about that confidence interval, they're saying we think that the likelihood that someone will vote for Clinton is or the likelihood that the country will vote for Clinton, we think something like 49.5 to 50.5 will vote for Clinton, or so. And we think something like 48.5 to 49% will vote for Trump. And there was actually a bigger confidence interval there because they were confused about how people were seeing it. So the data basically said, well, Clinton could win, or Trump could win. They thought Clinton was more likely to win in that case, but they said actually, in general, most pollers kind of had like a confidence interval like this for Trump, a confidence interval like this for Clinton, with also a relatively low level of confidence. Right there, 19 times out of 20, that thing, your confidence level was actually quite low. So then we think it's like this, even the confidence intervals had overlap. So people said, oh, the pollers knew nothing, they were totally wrong, they're screwed wrong. Well, sort of, but actually, even their confidence intervals included overlap. So it's very possible, even based on their data, there was going to be Trump winning and Clinton not winning. And in that case, Trump won based on their electoral system, but actually Clinton won the popular votes. So she got more votes, but he just won more seats. So it ended up that the polling wasn't all that bad, but it didn't show what actually happened. And this is one of the issues with polling data in general. Okay, blah, 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 Mr. Bush talking politics. Let's move on to a little bit more of a concrete example. Okay, a golf example.
Oh, finally, something.
Oh,
Golf!
what do you mean? Golf is not okay.
Golf is fun.
Ooh.
These people over here have been starved for life, very sorry. So to determine the mean mass of golf balls in a factory, they did this sample. Now, they said that the mean mass of golf balls produced at our factory is 45.6 grams plus or minus 0.3 grams. And these results are accurate 19 times out of 20. 19 times out of 20. So first of all, confidence level, what's that talking about?
The confidence.
Right, how certain they are. 19 times out of 20, we could just say 95%. 19 out of 20 is 0.95 or 95%. And what's the interval that they're confident, that they're 95% confident about? What's that interval? Well, they're confident that it's within 0.3 grams of this 46.5. We could say it's 45.3 up to 45.9. They're saying we're 95% confident that the average is somewhere in here. Based on our sample, we're 95% confident that it's somewhere within here. And what was the margin of error in that confidence interval? It was 0.3. Right, that was the amount from the mean that they're saying. It's somewhere here. So based on this, is it likely that the mean mass of golf balls is 45.1 grams? No, it's not likely. Because that's outside the confidence interval. So no, it's not likely. It's possible, but not likely. And is it possible? Yeah, it is. Yeah, it's pretty close to interval. It's what they said is there's a 95% chance that it's somewhere from 45.3 to 45.9. Yeah, exactly. But it's small. Actually, it'd be even less than 5%, right? Because 5% is saying it's anywhere outside that. And this is outside. That's close. Right, probably 2.5% chance that it's below 45.3. Which could be 45.2, 45.1, or 26, or whatever. By the way, on this interval, where would you think the Z score for this would be approximately? What would be the Z score for something in this situation where this set up 45.6, but instead it's 45.1? What do you think? Yeah?
Oh, I'm a good person.
What? Martin, here's your point right here.
I'm a good person. I can keep up on
Yes, I heard it's by the being.
Oh, I guess, okay. No, the margin there is saying, plus, so it's from the middle. In this case, 45 points. Plus, well, no, the Z score would be pretty negative, but we don't know exactly. I would say approximately. Yes. Okay, lots of chatter going on. Let's bring it back. This isn't tough. It's pretty hard. In general, this is pretty difficult, right, Tia? Great. Okay, 2011 Canadian federal election. Anyone know who's a good good politics buff? Who knows who won the 2011 federal election? I'll give you a hint. 2015 is when Trudeau was elected. That was the last election I won. You were 3. Okay.
No, I was talking about the war.
So, in this, these were the four polls which were trying to figure out who was most likely going to win this election. And this is what these polls were saying ahead of the election. Now, first of all, look at the columns for number and sample and margin of error.
Yes.
Based on this, how do you think the number in the sample affected the margin of error? What would be the correlation? Nathan, you want to help him? That you'll bail it for Nathan because he was not listening at all. The bigger the number in the sample, the lower the margin of error. Yes, they're inversely correlated. Yes, larger sample, smaller margin of error. Or put more simply, if we have a bigger sample, we can be more confident in the results. Right? Or we'll be more confident we have a smaller margin of error. For each polling firm, let's calculate the 95% confidence interval for the percentage of Canadian voters who would vote for the New Democrats. And let's complete the table. And you'll notice that up ahead it says this margin of error is accounting for a 95% confidence. So the margin of error is saying what they'd be 95% confident about. So let's try this first. The Harris poll, it's saying that the New Democrats, they were 30% plus or minus 3.1%. So what would that interval be? Well, what's 30 minus 3.1? Nice. So from 26.9% up to the top end of that interval? 33.9. Nice. So the confidence interval for this would be from here to here. Okay. How about Angus Reid? Angus Reid had more people in the sample, so has a smaller margin of error.
I'm going for Angus.
You're voting for Angus? Nice.
Yeah.
Now this is just a polling company. They're not voting for them, but you'll give your data to Angus. Is what you're saying? Jet is willing to be sampled by Angus because he likes their name.
Who's the Coast Research?
These are just different polling companies.
Oh, that was the first.
So Angus Reid says they think 33%, plus or minus 2.2. So 33 plus or minus 2.2. So we have 30.8 up to 35.2. Okay, Nanos has a 3% margin of error. They thought 30.6. So 30.6 plus or minus 3. So they're going from 27.6 up to 33.6. And Ecos, they are saying there's a 1.8% margin of error in theirs, and they're suggesting probably 31.2 plus or minus 1.8. So let's see. 29 points. So you see what I was doing here? I was taking their polling data. I was applying the margin of error to it to find what the interval was.
This would be for Ben.
Hey, by the way, before we move on to the question here, if you were looking at these, what would you guess was the percentage that voted the NDP in that election? Just based on these, what would be your guess? And what I'm really asking is, yeah, what's something that's in all of the intervals? Yeah, 30, that seems fair. But really, you could probably look at this and say, okay, which ones are excluded? It seems like anything under probably 31, anything over 33 would probably be a bad guess. Probably something like that. How about this? How about for the Conservatives? And then we'll compare them. By the way, we can just put in this data here. See what it does.
I feel like it goes so much in politics.
No, too much. It's too much. I had experience.
Whoa.
Yeah.
You know what I'm going to do to make this easier on myself? I'm going to open a book so that I have the numbers in front of me as I'm writing over. Well, this is just the same book as you.
Yeah.
But yes, fair enough.
Open your mouth. There's no way you got Oh, I have 4 of them. 4 of them. And I was laying there for 3 hours.
Okay, first of all, I have not copied this wrong, right? These are all the same. So now we'll just do the Conservatives. The Conservatives, you'll notice the numbers are higher in general. More people voted for the Conservatives. But the margin of error is the same. So the Conservatives, for the Harris poll, is 35 plus or minus 3.1. So they had from 31.9 up to 38.1. So this is
The con.
the cons. There we go. Angus Reid, they got 37%. They were confident within 2.2. Up to Nanos thought 34.
We're actually soft right now.
Up to 40. And Ecos 33.9 plus or minus 1. Cool. By the way, you might notice here, the Liberals were clearly in third on this polling. That actually had been the case. Before Trudeau won the majority government in 2015, the NDP were the official opposition. Right? So it was the Conservatives as a government, with the NDP as the opposition. The Liberals were in third. And then under Trudeau, they had a big resurgence. Yeah, now, but I'm saying in the 11 election, the Liberals were almost it's crazy. They went from being the third position into becoming a majority government. It's a very significant election. Yeah.
Okay,
Okay, anyways.
so you're telling me Trudeau's been as prime minister for almost 10 years?
Yeah.
I don't think that's a lot.
He's one. His thing was prime minister for like 30 years. We determined between where he was. He won for like something like 10 years and years, then lost for 4 years and then won again. Bennett?
Put a bow right there.
It was during the okay. In which of these polling firms was there no overlap at all? Let's look. Hey, the chatter is ridiculous. Stop. I'm in the middle of teaching. As I suggested, this is a pretty hard lesson. The best way to deal with hard lesson is not to check out topics of things. The best way to deal with hard lesson is try to lean in and figure it out, okay? So in a case like this, here, which of these polling firms is there no overlap? Or in which of these polling firms would they say confidently, we're confident the Conservatives will get more votes, or we're 95% confident the Conservatives will get more votes than Liberals, right? Which of them has no overlap? Let's see. Well, yeah, because Harris, up to 38.1, down to 31.9. This one, up to 33. Okay, so that whole 31.9 to 33.1 is overlap. Possible. Angus Reid, 34.8, but this one comes up to 35.2, okay. This one, 34 to 40. Oh, Nanos, yeah, not quite. Hey, Nanos Research, not quite. They don't quite overlap. Nanos Research is 95% confidence that the number of Canadians who vote Conservative is more than the percentage who vote NDP. Which of the polling firms is there an overlap? Well, the other three. Harris, Angus, Eagles. Now, in which of the polls can we say that we're 95% confident the NDP will receive more votes than the Liberals? Or what that's asking is, which of these ones has a confidence interval between the NDP and the Liberals? There's no. So looking at these, I see that in all of them, the percentage who would vote NDP is higher than the percentage who vote Liberal, they thought. But do any of them have overlap? Well, let's see, the top of the Liberals on the Harris 25.1, the bottom of the NDP, okay, that one, no overlap. Angus Reid, no overlap. Nanos Research, no overlap. And Ecos Research, no overlap. So which of them can we say with 95%? All of them. None of them have overlap. Then what happened? Well, the NDP did receive more votes than Liberals. These polls were right. Actually received a lot more. They were the official opposition. The Liberals had like very few elected officials. By the way, I think that there's a very good chance this next election you'll see a very historic change where the ruling party goes down significantly. Anytime where there's kind of significant turmoil like there is right now, that party often loses a lot. We'll see what happens for the better Liberals, but it'll probably be an election which I guess we'll see. it'll be interesting to watch polling research as the election comes forward.
Is the election in October?
In Canada, you don't have like a time where the election has to be, like in the States. So we don't know. The election has not been called. It will have to happen at some point. That's a very good guess. Okay, and one more. Which of these are we 95% confident that the greens will receive more than the block, or the block will receive more than the green? So looking at these, which ones have the block receiving more within the confidence interval? Looking at it, I see the first one, block is lower than the green, clearly not that one. The second one, the block is 6, the green is 4, but plus or minus 2.2, so there is an overlap. 5.5, 2.2 with 3% overlap, nope. And 6.4 to 6. Which of them can we say with a 95% confidence? Well, none. None of them are 95% confident because the confidence interval is overlap at all of the confidence intervals. If you go on the table on the back page, or on the last page there, and you look at block BQ green, and you take the margin of error and apply it, so like the block on Harris decimal poll, they're saying that we think that somewhere between 1.9 and 8.1% Canadians will vote for the block. And that's that. Bloc Québécois 5% with 3.1% margin of errors. And let's just go back here and take a look at this here. So if we're looking at this first poll, 5% and 7% with a 3.1% margin of error. They're saying this one could be somewhere from 1.9 up to 8.1, right? 5 plus or minus 3.1%. And this one, the 7, could be anywhere from 3.9 up to 10.1. Now they think it's likely the Green Party will receive more votes than the Bloc. But they're saying we're confident that somewhere in this range, within the, we have 95% confident that this will happen. We're 95% confident this will happen. Well, they're not confident that it doesn't overlap. They're not confident that the Bloc will receive more votes than the Green. And similarly, in all of these, their confidence intervals overlap, so none of them are willing to say, oh, we're 95% sure this will happen. Just like, does this range have any overlap on this? So like, if you were on a number line, it's a really good question. So in this case, the number line, do you like my perfect number line?
Yep.
It's
Actually, completely perfect.
Thanks. You get plus 2%. Flattery works, obviously. Okay, so they're saying the Bloc's amount that will vote for them, we're 95%, it'll be somewhere from here to here.
There.
We're confident that the Bloc will receive something like this percent of the vote. And we're confident that the Green... Oh, yeah, other way, sorry, that was the Green. Oh, sorry, no, I just included all of them on one, my bad. Okay, so 1.9 up to 8.1. They're confident of that. And they're confident that the Green will be somewhere in here. We're saying it needs to fit somewhere in the data. Glad that you're not distracting other classes like those is. So they're saying we're confident somewhere in here, and the issue is these overlap. The 95% confidence intervals overlaps, so they're not really saying much in terms of which will get more. And that was the same with all of these ones. Is all of these confidence intervals will overlap. So none of them will be willing to say with 95% certainty that one is more true. Now, you're going to get a chance to look at more of that, but I should keep going because we also need to think about sample size and how this impacts things. So if you want to be 100% confident about, let's say, our school height example, you would need to measure every single person.
I will do that.
Not realistic. David's going to do it, but most people won't.
Try me or do it.
No.
Now, suppose the sample mean is this, and we state a confidence interval plus or minus 1 inches. If we had measured, say, more than half the students in the school, our level of confidence would be pretty high, maybe over 99%. If we measure the heights of, say, a quarter of the students, our level of confidence would still be very high, but not as high. right? We'd say, oh, a quarter of the students, depending on how we had picked them, which is probably a good sample, but maybe not fully. If in our sample we'd only measured a few students in our school, let's say that, think about this situation. If I want to find the sample, or the average height of our school, and I only pick down here senior boys basketball team as our sample, is there a possible issue? There's actually several possible issues. Number one, basketball is a height selecting sport. Generally, people who like basketball are successful at are taller. Number two, we also picked an only male sample. As we have several issues, it's quite unlikely that would be a very good example in this case. If we take this classroom, pretty good better. We have grade 10s, 11s, and 12s in here. There's nothing that made math more beneficial to taller or shorter students. We probably do have more, we probably have more grade 11s and 12s in here, so there's probably still a slight issue with that. But maybe if you took all of my classes, I teach a Math 10-3, and Math 10C, and Math 20-1, 20-2, we probably have a decent sample of display in that case. But it'd be less certain than if we had like half of it. They took some. Now, how about this? The company produces hockey pucks. League regulations say the puck must be within this weight, 164 to 170 grams. Now, production equipment is set to produce pucks that have a mean mass of 167. The standard deviation is calculated to be 1.1 grams. Wait. Standard deviation. I'm not in this same lesson. What does standard deviation mean again? It's like if the average is 167, and we have a bell curve, that's not very bell curve. Each step that's like one z-score away from the mean is one standard deviation. So it's saying a z-score of 1 is a standard deviation of 1.1. Quality testing is used to determine if the pucks produced meet the required standard. So to ensure that a small number of pucks that are produced are rejected, they want to make sure that the mean of the pucks is somewhere between 166.7 and 167.3, or confidence intervals of from 166.7 to 167.3. And they found that if they need a 99% confidence level, they need a sample size of 89. If they need a 98% confidence level, they need 73 sample size, and on and on. Now, let's take a look here. So confidence level, sample size. It's asking what confidence level is the company using for their quality control test. Now let's look here. Quality control. It's saying it's set to produce this with a standard deviation of 1.1. They want to make sure that the mean mass of pucks is in this range. So what confidence interval are they using here? There you go. 166.7 up to 167.3. So what's the margin of error? 3.3. So how many pucks should be weighed in each sample if the company wants to ensure the mean mass is in that range 49 times out of 50? Which of these is 49 out of 50? 33. They should measure 73. If they measure 73, and the average of the 73 is within that range, they can be 98% confident. Okay, that's yes. We'll leave those for now. So last one. This is actually just, I want you to interpret this, and I'll talk this through with you, but I'm not going to write it down. So I want you to write this down. You can use my words, or you can use other words, but I'm not writing it down for you. You can't just sit and copy. So what I'm saying is you try listening. So let's read this for you. Recent surveys showed Canadian high school students, I know some of those. Canadian high school students spend an average of 1.5 hours per day accessing the internet. A long time ago. And 1.75 hours, that's 1.5 hours per hour.
Per hour?
1.5 hours per day, access to the internet, and 1.75 hours being completely accurate. I like how Jaden's initials made. Wait, how old is this? He's absolutely right. Very old. Recent survey. Let's change that.
Old survey.
Ancient.
Old survey. I think recent.
anyhow, this survey This survey says it's accurate within 0.2 hours. So what's that 0.2 hours? What part of the data is that? Is that like the confidence interval or the margin of error or the mean or what? Margin of error. Okay, the margin of error is 0.2 hours. And 24 times out of 25, what's that say? Right, confidence level. Yes. We're 24 to 25 confident. We're 96% confident about this. And Jason rightly says I'm 95% not confident this is true. Okay, but anyways, so interpret this. Say mean, margin of error, confidence interval, confidence level. Okay? Say what that's it. Do it, go. It helps you grow their team. Alright.
Don't do it back out. Don't ever cut it. Cause the tent on your finger. I took it. You know who done?
Now let's put our brains together. No, I can have back. And bringing you them back in the Monday, 16th of No. Think about it. Let me think about it. Like I'm theorizing. So think about it. Maybe if you hit it with the 1.5 per day, you know, and then you hit it with 1.5 plus 0.2. So it's 1.7 then minus that because it's plus and minus. So this range, or whatever it's called, 1.7 to 1.3.
Would this survey be 96% confident to say that the average Canadian high school student spends more time on the internet, more time active than on the internet? No, good, because the confidence intervals do a
I did not
lot.
read it.
They'd probably say there's probably some degree of likelihood in this data that they're active more often than they're on the internet, based on the fact that if you had made the amount you need to be confident less, then the margin of error would have gone down. It's likely they still would think that it's more likely they're active than on the internet. And obviously now that data would be flipped for many people, but that's what this data is saying. There's a 96% chance, 96% confident that the mean internet usage is within 1.3 to 1.7. And they're saying we're 96% confident that the mean active is within 1.55 to 1.9, somewhere. That's what that is saying. Okay. For today, in this next half hour, I would like you to work on, I thought I wrote it down, sorry. Once again, didn't write it down here. I'll just tell you. I would like you to work on 1, 2, 4A, 5, 7, 8, 10.
Only 4A.
That's all I want you to do.
7.
So 1, 2, 4A.
4A, 5.
Yeah, 4A. 1, 2, 4A, 5. Probably diesel.
No, there's one more that I'm cutting out. 7, 8, 10.
I got red pepper.
And if you finish, hey guys, it's definitely worth going back and spending time on Z scores. It really is hard to break a lesson up just break in the middle. You've had 2 weeks since you've done anything with standard deviations or with bell curves or anything. So I would say if you finish this, definitely go back and look at Z-scores and deviations. Yes.
You know what I did?
You know what I did? I'll be right there.